Good morning and afternoon, everyone, and welcome to our today's webinar and our Tech Talk session. My name is Farhan Razi, and I just want to quickly check if everyone is able to see the screen and also hear me loud and clear. Okay, so again, welcome to our Tech Talk session, accelerating the natural gas innovation, bridging industry needs with clean tech solutions. My name is Farhan Razi, and I am the manager, contracts and project management for the industry grants program here at NGIF Accelerator. My background is in mechanical engineering, and I hold a PhD in sustainable hydrogen technologies. In my role here at NGIF, I am responsible for managing the rigorous process that brings early stage clean tech solutions from the lab into the real world operational environments of the natural gas sector. I am delighted to be your host today. Next, please. Before we dive into today's agenda, just a few quick housekeeping items. Please keep your microphones on mute to ensure we have clear audio experience for everyone. We encourage your participation. Please use the chat box to submit any questions throughout the talk. I also want to mention that we are recording this session for those who couldn't join us live. And lastly, there will be a brief survey at the end of the webinar. We truly value your feedback, so please do take a moment to fill that out. Next, please. To begin today's proceedings, I will start by providing a quick overview of NGIF Accelerator to tell you about who we are, what we do, and what we aim to achieve. NGIF Accelerator is a Canadian not-for-profit established in 2016 to drive the commercialization of clean technologies within the natural gas and renewable natural gas sectors through pilot projects and industry validation. The organization has approved over $32 million in funding across 114 projects, successfully moving 13 technologies to commercial availability and securing 10 Canadian industry adapters to date. Beyond general grants, NGIF Accelerator manages high impact initiatives like the NGIF Emission Testing Center, which is partnered with University of Calgary and Tourmaline Oil, and the Methane Reduction Demonstration Program, which opens its next global challenge in September 2026. Next, please. To set, to set the stage for today, the mission of the NGIF Accelerator is clear. We are here to de-risk and accelerate the early stage technologies to market. Technologies that can help reduce emissions from the natural gas sector. We know that for many early stage startups, the path from a great idea to commercial market adoption is fraught with challenges. NGIF is unique, first of a kind, industry-led model that helps bridge the gap by providing the critical components necessary for success, namely pilots and field trials for industry validation, capital, and access to market that only a program like ours can offer. Next, please. Our flagship initiative, the Industry Grants Program, is an industry-led non-dilutive funding model. It is designed to enable technology de-risking by providing capital and the real-world infrastructure to innovators, essential to advance their technology readiness levels or TRLs. Every proposal we receive as a result of our funding competition goes through a rigorous vetting process by our industry peer review panel to ensure that every technology we support is technically sound and ready to move the needle across the natural gas value chain. What makes this program truly unique is the coalition of the industry leaders standing behind it. We are backed by a diverse group of companies representing both the upstream and downstream sectors of the natural gas value chain. The following natural gas producers form the core of our upstream membership, including Canadian Natural Resources Limited, Tourmaline Oil Corporation, Arc Resources Limited, and Birchcliff Energy Limited. While our downstream members representing the natural gas utility sector include ATCO, Apex Utilities, and Bridge Gas, Fortis BC, Pacific Northern Gas, and Sask Energy. Next, please. We focus our support on the high impact areas that will define the future of energy, such as methane mitigation, carbon capture, utilization and storage, low carbon hydrogen, renewable natural gas, energy efficiency, digital transformation, and water management. Next, please. Our panelists featuring in today's webinar represent a cross-section of the energy sector, featuring technical expertise from major utilities, international business leaders, and the founders of cutting-edge technology firms. I will now turn it over to our speakers to provide a brief overview of their background and the impact their organizations are making in the clean tech space, starting with Shane Dunbar from ATCO. Over to you, Shane.
Perfect. Thanks for that introduction, Farhan. So I see that I've got a blurb up on here. I'll probably be repeating most of this, but I'm Shane Dunbar. I'm with ATCO Gas and Pipelines. We are the largest natural gas utility in Alberta, the province of Alberta in Canada. We serve about 1.3 million customers in the province. I've gone through a variety of roles here at ATCO over the last 8 to 9 years, from engineering to construction management, and now I'm lucky enough to be kind of in the R&D space. I'm specifically in our project development and strategy team. And we do lots of different stuff, but how that specifically relates to what we're talking about here today is I'm the representative for ATCO that sits on NGIF. So I get to look at all the cool projects that come through and see, their relevance and usefulness and what we like or, want to see more about them. So yeah, that's a quick intro from me. I think I'm passing it over to Taryn.
Yeah, hi, good morning. Thanks, Shane and Farhan, both for your introductions. I'm Taryn Humphreys. I'm the Vice President, International Business Development at Qube Technologies. My background, I'm an engineer by background as well. I worked as a development engineer at the producers for about 15 years before joining Qube. That's a lot of our backgrounds at Qube. We've come from the producer side to really understand the challenges of what the industry is facing. I've been at Qube for 5 years, and I've been helping grow our team and our product line, both in Canada and internationally as well. So just helping customers use continuous monitoring and our other product suite to really understand their methane emissions, help with reporting, regulatory initiatives, and ultimately just operational efficiency, usually using continuous monitoring and our product suite. I will pass it over to James.
Hi, everyone. I'm Jim Conton from Harvest Systems, also a professor at McMaster. Harvest is a spin-off company out of McMaster, and we're focused on helping the restaurant industry tackle one of their biggest challenges right now is affordability. If you've ever been into a restaurant, there's a lot of waste heat. In particular, ovens, fryers, and other cooking equipment based on natural gas dump as much as 90% of their energy up the chimney. And we saw this as an opportunity, and we created a company solely focused on this right now. So we developed a fuelless heating system that captures waste heat directly from appliances. We worked with NGIF to support working with Pizza in particular. And now we're focusing on full service restaurants, hotels, supermarkets, institutional players. Focus on developing not just a heat recovery technology, but really a broader microthermal network directed to supporting restaurants. What makes this really interesting is we're just hedging energy costs for our customers. But at the same time, we save CO2. So this has been a really interesting adventure for us, and we're really just getting started right now. Thank you.
Hi, I'll pick it up from here. My name is Eden Prabhu. 25 years ago, I came to the realization that nobody in this world is using gas that is less than 10% methane strength for anything because it doesn't burn. And I came up with this one scheme after another. And in these last 25 years, I've ended up with 10 patents. And we now are focused on what we call gradual oxidation. We can oxidize methane down to 0.2, 0.3%. And I have to give a lot of credit to NGIF because when we first applied to you guys, you asked a dumb question. Can you handle lean burn engines? And I started to say no. And then I said, well, let me tell you tomorrow. And now our main focus is lean burn engines. So Farhan, you and your predecessors have made a big difference to where we stand today. All of this stuff is because of a question that you asked.
Thank you, Eden. And thank you to all the panelists for providing such wonderful introductions. You truly are a reason that we are all sitting here today. Without further ado, I will officially begin the proceedings of today's webinar. Starting with Eden, since we left off with you, question number 1 is for you. So Eden, the Accelerator project is an ambitious R&D push for methane mitigation. Can you walk us through the primary outcomes of your project and what made the lab to field transition worth pursuing?
Do you have 4 hours?
We will kindly ask you to wrap it.
Let me just go briefly.
Yes.
Combustion is the most universal means of generating energy from fuel until fuel cells came along. All combustion is incomplete because of the nature of the beast. You know, it's a sudden, rapid explosion. And so all combustion results in gases that escape. We tried to go to leaner and leaner and leaner, and we ended up with 0.2, 0.3% methane. And we can now oxidize that with what we call gradual oxidation. And after a few bumps on the road, the technology has now reached the point where we've got some funding from NRCan to build a system for a 1 megawatt unit, and we're scaling up. And gradual oxidation, once you have solved the riddle, is really, really simple. So scaling up is easy, and it destroys not just the methane, but all the VOCs and all the CO. So it makes the engine as clean as a gas turbine or a fuel cell. And we're starting up on that project right now. And NGIF has been a partner, as I said, from day one. And next year, we'll have a system running in Alberta at a 1 megawatt engine.
Thank you, Eden. That was a very quick and insightful answer to the question. And I will now turn to Taryn. Taryn, you have hit significant scale with 1,200 plus sites. Looking back at your NGIF project, what was the most important milestone that proved to the industry that continuous monitoring was not just viable, but a necessity?
Yeah, thanks, Farhan. So for us, the turning point wasn't just necessarily more sites. It's when operators actually started seeing the emissions, seeing the data that they would have otherwise missed without continuous monitoring in just traditional snapshot surveys, and then being able to act on that data. And so that's that turning point of okay, this is interesting data into how are we using the data, and we can't operate now without this visibility in between. So we know that emissions are really intermittent. They can occur at any time in varying duration and varying size. And so traditional approaches just don't catch those. And so when you're able to demonstrate to operators that continuous monitoring fills in those gaps and can reliably detect and quantify and localize those emissions in real world conditions, that's when it starts to be able to be more viable and that operational must rather than just a nice to have. So that's where really we found it. It's not just more data points, it's consistent, reliable detection in a continuous manner that can really build that confidence for operators.
Thanks, Darren. Jim, next question is for you. The power system is an industrial application for restaurant settings. What are the early project goals and how did they evolve as you moved from the lab into the live restaurant environments?
So when we developed the power system, pizza oven waste energy recovery system, our goal was to recover heat. And we knew because they were 90% inefficient, they were dumping that much energy, we could do it. Once we got into a commercial environment in a live restaurant, we realized they don't use as much heat as you really need. We're only putting our system on one appliance right now in a pizza restaurant, heating all of their hot water. So then we really quickly realized we need more sources of demand. So we were able to evolve our system, not just from delivering hot water, but doing sanitation, doing makeup air. So essentially what we developed our technology into is a small microthermal network, really to focus on where are the key pinch points of a restaurant, where can we save the most money? In addition to the support and these pilots, we had to really focus on the regulatory environment. Surprisingly enough, standards were completely out of date. And it took us quite a long time, in fact, 7 years to change it. It wasn't that it wasn't unsafe. It was the regulatory environment hadn't evolved enough to do heat reclamation from naturally aspirated appliances. So what happened along with the pilots supported by NGIF, Jeff Gerard, COO, joined the technical committee. He worked and promoted the changes to the regulatory standards, and eventually authored the standards, got them approved, and now we're actually in the midst of working with CSA to get stamps on our product. So it was a huge process to get from 7 years ago when we incorporated our company till today.
Thank you, Jim. That was a fantastic answer. And I hope that the journey was not only fruitful, but also very exciting because there were quite a lot of lessons learned along the way. Shane, coming to you. Operators like ATCO are essential for field demos. We are aware of that. What is the biggest strategic benefit ATCO gains from being a part of the NGIF ecosystem? And how do you decide which tech projects are worth the operational risk?
Yeah, it's a big question. We'll see how quickly I can answer it here. I don't want to pump NGIF tires too much, but I'll say it's hard to name maybe just one benefit. I'll touch over a few quickly here. The first is probably relatively obvious, but it's just being able to stay connected with innovators, new technologies, and our peers, of course, as well. So, NGIF is a platform for us to focus on conversations with other industry operators about challenges they face and where they're going, which allows us as ATCO to reflect on our own challenges and similarities or differences. That really helps us flesh out kind of where we exist in the ecosystem and look at any similar hurdles that we have together or unique challenges. Another big benefit is getting to see firsthand these innovative projects and technologies progress forward, which gives us a much better insight into what's a good fit for our operations. It also provides a much cleaner communications pathway. We might not have even been aware of these before, but now we're looking at these new technologies. And if we do identify a fit, we probably already have the right people in place to be able to chat with. Now, the decision on new technologies and their operational risk can be put into let's say 2 categories, like a pilot project or actual implementation after a pilot project, usually. So if we're talking about a pilot project, the focus is to de-risk that technology and help move that forwards to commercialization. So success can be determined by improving the technology, lessons learned, inching closer to commercialization, a lot of other metrics. If we think a technology has a capability to improve our operations, then we weigh that against what our contribution would need to be to run a pilot. How much in-kind labor, land, in-kind support, communications, all those kinds of things. What's required? And so we have two sides of a scale. How much is the impact, or how valuable is the technology to our operations, and how much work do we need to do to put it into support a pilot? So that's kind of all the stuff that we would look at. For actual implementation, it's a bit more challenging. As a gas utility, we're concerned about a lot of things: reliability, safety, resiliency, affordability, environmental metrics. If you can prove that you can have an impact on one of those without impacting, say, affordability in a major way, that's of interest. Now, something about when we think about our jurisdiction, at least in Alberta, there can be a balance, and there is a balance between something like affordability and environmental impact, which we often see at different sides of the scale. So we're regulated by the Alberta Utilities Commission, whose job is to ensure that as utilities, we're working in the best interest of the public. Right now, affordability is a big concern of the general public. So we have to keep that in mind when we look at opportunities that might have a reduction in environmental footprint, but also have a negative impact on our ratepayers' bills. So those are very important things that we have to be juggling.
Thank you, Shane. I think this was an answer that a lot of the participants in today's webinar might be really looking forward to hear. So thank you for going about it in a lot of details. James, my second question to you: real world kitchens are chaotic. We know that. What are the most unexpected technical or logistical challenge you faced during the deployment process? And what is the biggest lesson you learned that you would be telling an early stage innovator today?
Absolutely. Chaotic, space constrained, and they have to be cleaned. So those were all key elements of what we had to deliver. On top of that, we realized what enormous pressure they're under: rising costs of food, rent, labor, energy. Energy's been going up in their industry about 5% per year for the last 20 years. So we were able to identify that. But then we said, okay, boy, we have to make our product have really, really great payback. We have to be in that 2 to 3 year payback period. The only way we're going to do that is to offer this modular solution that we can expand to a lot of different restaurants, not doing customized designs for every restaurant. So we created this modular design that's deployable for a fryer, for an oven, for a combi system, you name it, for back of griddles. One of the bigger lessons we learned was, who is our customer? So when we first approached this, we talked to Paul Goddard, CEO of Pizza, and really the environmental benefits, the carbon reductions, the sustainability goals were top of mind. And that was very, very important to him. But then when we started talking to the franchisees, they had really different priorities. Their priorities really focused on, what can you save us money? How much? Can you protect us from these crazy energy prices? And so once we realized that we had two different customers that we're selling to at the same time, it really put us in a much stronger position. From an equipment point of view, when you cook, it's like your barbecue. Right, you have hot spots, and your burners go out of calibration. So one of our first installations, we got a call from the owner, and they're like, "It's not working properly." And we go, "Oh yeah, we know, we can see it in our monitoring system. Something's wrong." And when we came in and we realized that their burners were out of calibration, and it came to us, well, we've got this great monitoring system to show how much we're saving, how much CO2. Hey, we can develop this as a service to tell them when their burners are going, when they're going out of calibration. And basically, we also learned it from day one. When we install it, let's calibrate it for them. Let's get everything up working perfectly. So we're going to even save more money right off the bat. So being in the environment was critical for developing our technology. I think that's the most important thing, especially if you're coming out of academia or out of a research lab. In rural deployments, you have to listen real carefully. You have to adapt real quickly, and to be honest with you, you have to let the marketplace shift and shape your technology. So instead of pushing a technology, you have to create a pull for your technology.
Thank you, James. I think this is something that's really important, and a lot of the early stage innovators would definitely benefit from the lessons that you learned along the way. Uh, the next question is going to be for Eden. So Eden, scaling your technology required significant technical refinement. Beyond the primary design, what were the hidden technical lessons you learned during your NGIF supported demonstration that now guide your future design iterations?
Okay, we started with 3D printing. We found that if you put 3D printing into your proposal, people are willing to fund. So we sprinkled, but I didn't know what 3D printing was, and especially for high temperature materials. So our first system, we spent all the money screwing around with 3D printing where the size was too small, the defects in manufacturer, et cetera, et cetera. So then I took a real tough decision and said, let's do it the traditional way. And that traditional way was not 100%, but we got laser manufactured heat exchangers and a reactor that was also made fine. And then there was an accident. During one of our tests, we noticed that this thing is oxidizing on its own. And so we pursued that, and we came up with another system that uses the self-oxidation, and we hit a gold mine. We found that all of the stuff you put in to make the transition to oxidation, you can just throw away. All it needs is time and temperature. And then we were able to reduce the temperatures. So we started with Inconel, and then we came down to regular 310 steel. And we could keep the temperature below 900. And as a bonus, something we were talking about, but we hadn't proven, we eliminate not just the methane, but also all the VOCs and all the CO. And since this thing is just a big piece of pipe, it's really easy to go to larger sizes. So we skip the intermediate steps because there's no use for a 200 or a 100 kilowatt system. We're going straight to the 1 megawatt and larger because that's what the industry wants.
Thank you, Eden. That was a really good answer. Moving to the next question, we have Taryn. Continuous monitoring depends on the data trust. How did you handle the skepticism of early operators? And what did you learn about data transparency that helped you gain that trust?
Yeah, thanks. So it's a great question. Obviously, these operators have so many different technologies. There's an evolving landscape in the methane world right now, and so they're needing to understand the technologies and what goes into them. So, you know, because the operators are using the data and the measurement and the technologies for using in the real world, making decisions based on that, having that operational background behind it, that trust really has to be earned from the technology providers. And so early on, Qube was really big on focusing on that transparency, showing not only our results, but sort of how we got there, and not, you know, we're not giving away all the details of our proprietary models in the secret sauce of it, but really how we come to our answers, doing side-by-side comparisons of our, you know, maybe early models versus later models. We do controlled release testing out at our own. We have a facility here in Alberta that we do that at. A lot of the testing then we did at the NGIF Emissions Test Center here in Alberta as well. And then being able to use that and iterate on that, having that detection limit transparency with our clients and understanding, you know, if we're missing something, why, if we localize to a wrong event, why, can we get that iteration loop of improving those models down the road? And so what we're learning is that, the trust is built from not just having perfect data, but being able to then have that consistent data, understandable data, how that can be worked into a real world situation. And what we found has been most beneficial is instances where we've identified an emission, there's an alarm that goes off, an operator goes out to check, and they're being able to verify that where Qube said the emission was happening was exactly where the emission was happening, and they're able to repair that and then see that return back down to baseline. And once you get that loop, that feedback loop, that's where you really start to get the buy-in and the trust from the operational side of things. And so that's what we've really been able to lean into. And as soon as you get that operational buy-in from the clients that you're working with, that's where it really starts to take off and be able to scale from there.
Thank you, Terry. So what I'm hearing is that the constant feedback from the consumers are something that are very important for you to constantly build on the shortcomings and the gaps within the technology. And as you are hearing those comments from your consumers and customers, you are constantly building on those.
Absolutely.
Thank you. Shane, next question is for you. You have seen several of these projects unfold in front of you. When an innovator struggles during a pilot, how does the collaborative environment of an NGIF project change how ATCO reacts compared to a traditional vendor relationship?
Yeah, the collaborative environment is everything, really. I mean, in a traditional vendor relationship, right, you probably got a single operator and a single vendor. So you have two perspectives, two sets of opinions on overcoming the challenge, etc. In the NGIF process, there's going to be multiple operators that are, involved and able to provide different opinions, perspectives, and solutions to challenges. And this is especially helpful because many of the operators have very different backgrounds and expertise. ATCO has expertise that differ even when we compare against other gas utilities in Canada, never mentioning, the upstream operators who are going to have very different and complementary skill sets. I certainly don't claim to be an expert across all the different types of technologies that we see coming through NGIF, which you had gone through at the start there for on, RNG, carbon capture, operational tech, demand management solutions, machine learning, and AI we see all across now, right? So it's like, I definitely am not an expert in the vast majority of those, but with all the different operators we have involved in NGIF, usually we can combine our knowledge to cover a pretty good swath of categories. So I guess that's a long way of saying that many heads are better than one or two in this case.
Thank you, Shane. And I would definitely agree on this, that the multidisciplinary collaboration that the various upstream and the downstream members of NGIF that put together such a strong bench strength that allows us to navigate to the different and the diverse portfolio of technologies that we look on a daily basis. Thank you. Taryn, question number 3 for you. As a company that has now been fully commercialized, how has the scaffolding provided by the NGIF Industry Grants Program positioned you for the global market versus the domestic one?
Yeah, thanks. So Qube's really grateful for the industry from the funding that we've had from NGIF. It's played a critical role in helping us de-risk the technology in real world operating conditions. And that's a big piece of it. Often when you're talking to new prospective clients, they want to know, where have you deployed, not just in the lab or in simulated conditions, but in real world conditions. So that allowed us to do just that. And then also with credible industry partners. NGIF has this large backing of so many respected names across the value chain. And so having those names behind it is a really big piece of it as well. And then having the validation, so not just technical validation, but then commercial validation to show that confidence in the solution under those real world conditions. And so as we've expanded globally, Qube right now, we're in 10 different countries, started in Canada, have moved into other spots in North America and beyond. But just being able to have that backing from NGIF, that understanding, and that acceleration ultimately from pilot to commercialization has been a really big thing. And so NGIF has really helped bridge the gap from just early adoption from innovation into adoption and then into more commercial scalability beyond. So that's been really a great part of this program, and we've been really grateful for that and our involvement.
Thanks, Darren. Moving to the next question, Eden, now that the lab engine test is complete, how are you using these outcomes to fuel your commercialization plan and future technology roadmap?
Uh, there's a lot of interest in the oil and gas business. They are bugging us to do something. And that started with NGIF in the beginning. They thought this is an unsolvable problem. So many oil and gas companies have come to us and said, can you put one on our system? And these are big, big units, you know. So what we've done is we have established several good companies in Calgary who will do the manufacturing for us and who can reduce the costs. And we are also gearing up to mass produce with these people. And we've got oil and gas companies lined up to take units. And maybe I shouldn't say this, but we lost a lot of our US funding when a certain event happened a year and a half ago. But big shock. I got a call 2 weeks ago that said that some of that funding is being restored. So we have a trump card, so to speak. And we expect to have just as much interest in the US as in Canada. And just so you know, the biggest engines are not in oil and gas. The biggest engines are on ships. They are 10 times the size, and we expect to be able to go to those ships who are running on LNG or something and make a big impact there as well. So we're doing stepping stones. Our motto is do the first one, prove it for 3 months, and then do the next one. And then we can start to do multiple units.
Thank you, Eden. James, how has the performance validation gained through your NGIF project changed your conversations with the investors and prospective new customers? You're on mute.
Always. So I don't know if you remember, but our first grant was approved in 2019, 2020, just before COVID hit. NGIF was fantastic. They let us sit on the opportunity until we came out of COVID and then started working with Pizza, our first customer. What it showed, first and foremost, was that it works in real world conditions, that it performs as we said it was going to be in the lab, that it has other operational savings, and we were also able to identify clearer what our market really was. It also helped us with the pathway through the CSA regulatory process, right? So we were able to use the pilots to train ourselves so that we could adapt the regulatory environment towards new technologies, and that gave our investors so much confidence. In fact, Paul Goddard, the CEO of Pizza, was the first investor in Harvest Systems. So he was our lead investor overall. And then beyond that, we've raised over $1 million. It's also helped us tremendously in terms of looking at new customers. We are working on pilots thanks to NGIF, with Recipe Unlimited. Huge opportunity there. Full service, 24 brands all across Canada, 1,300 restaurants. We're in discussions with the likes of institutional players, of hotel players, of supermarkets now. And a lot of them came and wanted to see the system, not in our lab, but they wanted to see it in the real world environment. So I think that has really been a huge benefit. And then there's also side things to be working with NGIF. Other organizations like NYSERDA, SoCalGas, GTI Energy, Enbridge IESO have all been in discussions with us. And now this is about, okay, we're going to start developing potential rebate programs, save on energy programs, like if you live in Ontario, those type of opportunities where gas utilities can reduce their consumption, their customers' gas consumption significantly. Great environmental impacts, but also capacity impacts. That helps reduce the payback. But they're also, to me, potential distributor channels, right? If Harvest Systems is up on Enbridge's website as, oh, they have a great saving on energy program, that's fantastic for me. So I think it's helped across all spectrums, which you can't do when you're working in a lab, in a research institute, in a university. You need to be in the field running these systems and seeing how they really work.
Thank you, James. I realize that the collaboration and the collaborative environment and the opportunities that NGIF provides its funding grant recipients are the ones that are game changers, because it's not only about de-risking, but it's also about connecting the technology providers to the potential customers. And with the role that NGIF plays in the ecosystem, I think that's something that makes the NGIF Industry Grants Program unique in its own way. Thank you. Shane, moving to the last question of today's webinar. From your side of the table, how is the success of these NGIF funded projects changing the way ATCO approaches its procurement of new clean tech over the next 5 years or so?
Yeah, so I talked about this a little bit already, but one of the biggest upsides for us is just being able to see firsthand how these technologies work, getting to talk to the teams, watching the results, and seeing them operate and gaining that additional level of confidence in them and the company behind them. So this is not going to come as a surprise to anybody, but as a utility, I'm inherently risk adverse, and trying new technology that has just entered the market can be a risky move. So sure, you can look at spec sheets and quotes and pitch decks and all these things, but everyone knows that there's going to be additional challenges, hurdles, and also opportunities that come up when you actually start to introduce these things into your operations. In a lot of cases, this can mean that even if it looks like a technology might provide a benefit, there's always an unknown risk factor that, you don't know what that's going to look like when it actually comes out onto your field, and how much dedicated resources are you going to need to implement that. But we get a significant amount of de-risking on that side through NGIF. We get to see these projects get implemented. We meet the teams. We learn about the people behind the tech. We see them working in the lab. We see them later on in the field. So when it comes to make that decision, we have so much more information to de-risk those unknowns that it really makes those benefits come through a lot clearer. And this all just makes it a lot easier to justify trying out a technology ourselves.
Perfect. Thank you, Shane. And with this, the webinar Q&A session with the panelist ends from my end. I'm very grateful to all of you for answering the questions in a way that I think would be very much beneficial and fruitful to the audiences that we have present in today's webinar. With this, I would now open the floor to the Q&A sessions from today's participants who are a part of today's webinar. And based on the registrations that we have, I see that there are a lot of people who would be interested in asking some questions from our panelists. And the first question that we have received in our chat is for Prabhu Energy. So Eden, question for you. Can you explain what happens to methane in your system? If it does not exist through the exhaust and there is no catalyst in the design, where is the methane gas stream directed?
That's a perfect question for me. Catalysts reduce the oxidation temperature, and that's why they work. We do not reduce the oxidation temperature. In fact, we raise the temperature of the exhaust to the oxidation temperature that it would have naturally. and then we're given it enough time to fully exhaust. So what we end up doing is raising the temperature from 400 C, which is the engine exhaust, to about 700 C. And at that point, it is already oxidizing on its own. And as it oxidizes on its own, the temperature goes up even further. And then we grab that temperature bump to heat up the incoming gas. And so it's a continuous system. Another interesting thing that we found is that once we set up the system for a lean burn engine, there are many, many places at a compressor site where gas is going up one way or another. Some of these sites have actual flares sitting in the corner. All that gas can be diverted into the oxiperator, which is operating at atmospheric temperature pressure, and all that gas can be oxidized without having individual systems for each place. We haven't proven that, but that is our next project. And we don't make NOx because we stay below NOx formation temperatures.
Thank you, Eden. As Dini has mentioned in the chat, you can, the participants can unmute their mics and ask any questions that you might have for our panelists. You can also raise your hands and we can allow you to ask your questions. In the meanwhile, I have another question, which is for Shane. Shane, what are the biggest barriers preventing clean tech solutions from being adopted at scale in the natural gas industry today? And what concrete steps can both operators and innovators take to bridge that gap faster?
Yeah, that's a heck of a question, one that I think about every now and then in my role for sure. So I'd say, speaking from my personal experience representing ATCO on NGIF and reviewing numerous projects, to me, some of the biggest barriers right now are a mix of cost and reliability. So again, speaking for myself as a utility, I really can't cut corners on reliability at all, as that might result in gas outages or issues during critical times when people's safety becomes a risk. Think in the middle of winter when it's negative 40 degrees outside. And affordability is also critical. I think for those in Canada, at least, we hear a lot about affordability concerns. It seems like every single day. And energy affordability is important when it comes to people's needs. And I don't want anybody to have to choose between groceries and their energy bill on a cold winter day. So, the cost of new technology is a really big factor as well. Now, in terms of what we can do about this, I'd say take into consideration maybe the uncertainty that is pervasive in society today, provincially, federally, but certainly globally. There's lots of stuff going on globally right now that lead to a pretty high level of uncertainty, which lowers everybody's tolerance for risk. And if there's a lower tolerance for risk, then projects or technology that are inherently less risky, that could be a smaller budget, or maybe not trying to jump through a bunch of TRLs too quickly, maybe innovating on a margin versus a completely brand new untested concept, those can be more appetizing. That doesn't mean that those are completely off of the scale either. Everything's under consideration, but generally from my perspective, when there's a ton of uncertainty, lower risk is something that's a little bit easier to grab a hold of.
Perfect, Shane. Thank you so much. The next question is, what is the source of fund in our program and how much of the project cost can be supported by NGIF? Can a project get funding from other governmental organizations and NGIF? Yes, I think I would be answering this question. So the source of our funds are the industry members who are the partners of NGIF Industry Grants Program. And how it happens is that depending on the different requirements of the various funding programs and the clean tech challenges, there is a certain cap that is set on the maximum funding that is provided by NGIF. Sometimes it is up to 50% of the total cost of the project. Sometimes it's capped at a certain dollar value, such as, let's say, $500,000. And definitely when a project is supported by NGIF, there are a lot of other co-funders to a given project, and those co-funders can be government organizations, private funding organizations. Um, right now, there is another question, that is there an open call and how to apply? So um, we have the next intake scheduled for September 2026. I would advise you to keep an eye on our website and the social media channels for updates. Uh, I hope this answers the question. I see, Prabhu, you have your hand raised. Please go ahead.
Yeah, I wanted to, and I put a question in for Taryn. Taryn, we can make power out of a stream that has only 2% methane. I've talked to all of the people doing the monitoring. Nobody can tell me what the concentration is. They tell me what the total amount of methane is coming out in an hour and a day. That doesn't help me. I need, if it's 2% or higher, I can do something. If it's below 2%, all I can do is destroy. Can you guys tell me what the concentration is at the point source?
We could, yeah, we could. We have a couple different products. One, we have an intrinsically safe device that could go right at like a vent or a stack or anything like that. The minimum detection limit on that is about 200 ppm. And then our fence line devices, the methane MDL on that is like a 1 ppm limit that we could get down to, and that's at a distance of about 100 meters. So very possible. We could chat and see if there's an application and see if we could do some monitoring for you to help with that.
I am going to bug you. Yes.
Okay, sounds great.
Okay. Next question is for Eden. The question is that once technologies are deployed in the field, how much visibility do you actually have into how they perform over time versus what was expected at installation?
Here's what we're planning to do. Many of the sites for these oil and gas compressor stations are way out in the wilderness. Okay, what our plan, but so you have gas, but you don't have power, and you're remote. So we're going to take a little gas, make a little power, set up a communication system, and monitor everything we do from a central point. And once you set up that data communication channel, we let everybody else use it, because all kinds of people want to know what's going on. And once you set up the system, it's easy.
Thank you. Thank you, Eden. The next question is for Shane. How about we get a question from the audience? Yes, I see a hand raised. Christopher, I guess it is. Please go ahead.
Yes, so Chris Bush, Catalyst Agri Innovation Society in British Columbia. We built the first on-farm biogas plant here back in 2010 and worked with the team at NGIF in 2019 through the COVID Black Swan, we'll call it. I reached out to all of the speakers and because I want to talk to you all. We're about to move on what we developed with NGIF, building a new facility here, and you've all got something I think we need for what we're about to do. So I'm eager to talk to you all at your earliest opportunities.
Absolutely, Christopher. Thank you. And I understand that definitely the time when we had last connected was a time that was not ideal for the world. But I think today the opportunities that we are looking at are much more promising, and the market is much more encouraging. So definitely, we would definitely like to get in touch with you you can get in touch with me through the email, or I'm happy to jump on a call with you.
Yeah, another piece dropped last May that we hadn't even conceived of that makes the whole thing 10 times better. But I mentioned in the chat, during our event, we had something happen with one of our project partners. They saw something on a bench and asked about it, and it turned into an enormous breakthrough. And if we hadn't been doing the work that you funded, we would have never had it. And it will literally change the world of agriculture. So much gratitude. Like I said, the NGIF program has been very good for us.
Thank you, Christopher. I think that this is the exact objective that NGIF has, to support de-risking of the technologies that have the potential to address the natural gas sector. And I'm very glad that NGIF was able to help you achieve that. And also, it's all about, as Eden mentioned earlier, asking the right questions. If you never ask a question, nobody will ever get into finding an answer. So thank you, Christopher. The question was for Shane, that how are operators within NGIF prioritizing carbon utilization pathways such as solid carbon or advanced material production relative to traditional emissions reduction approaches like the capture and storage?
Yeah, so unfortunately, I'm not the best operator in the NGIF world to ask about this, because we don't really do a whole ton or really any carbon capture and storage in the eco gas and pipelines utility world. If I'm capturing carbon emissions, it's likely repurposing the methane emissions on site for reinjection into the utility system, or taking some slipstreams and generating some on-site power. But we don't have the same use cases that, for example, a lot of our upstream operators would have for carbon capture and storage. So yeah, I don't have too much else to say on that one, unfortunately.
No worries. I think there is a question that James, you can answer. What do you see the role of waste heat to power applications in the industry?
So we spent a lot of effort on thermoelectric generators to begin with. And so thermoelectric generators are solid state devices that convert a temperature difference into a small amount of electricity. And we integrated that into our system. So our system is a completely adaptable to power generation. However, what we found was it wasn't the energy generation that was important, it was the resiliency that was important. Giving the opportunity for the restaurant to stay open during a power outage was the real benefit. Because it's way better to save a watt than generate a watt. And that's really what we found, is if you can save a watt, especially of electricity, that is great savings. Now, you don't save as much on carbon emissions in places like Ontario, but when you save a watt of gas, you save carbon emissions as well as saving money. So I think that there's a role, but I think the role is not about generating electricity, it's about providing more resiliency to our customer base.
Thank you, James. And with this, our Q&A session comes to an end. To all the participants of today's webinar, if there are any questions that you might have, please send it my way. The email is mentioned in the slide, and we would definitely appreciate you all to scan the QR code and provide us some feedback based on how today's webinar went, and what would you like to see more in the future webinars, because your feedback is going to play an instrumental role on how we structure our next webinars. While everyone is providing their feedbacks, I would like to once again take a moment here, thank all of our panelists, starting with Shane, Taryn, James, and Eden, for joining us today in this webinar, for providing your insights through the experiences and the lessons learned that you had as part of the industry grants program funded projects with NGIF, and really appreciate the insights that you all shared. Shane, thank you very much for representing ATCO as one of our industry members from the downstream part of the natural gas supply chain. And I hope and wish that we can meet sometime else in the future to answer some more questions and help the upcoming and the aspiring technology providers to get into a part of the ecosystem in terms of contributing by innovating technologies that can help the natural gas market. Thank you once again to all the panelists. Thank you everyone for joining today's webinar, and have a nice rest of the day, and see you all very soon. Take care. Bye-bye.
Bye-bye.
Bye, everyone. Thank you.
Thank you.
Thank you.
I will be in touch for